Hello guys, we back here in Tekniikka High Tech today. This is our sixth lesson about the C programming language, of course. Hope you liking my course here. Please subscribe my channel on YouTube, Tekniikka High Tech. Also put a like on Instagram, follow us, and also on Facebook, Tekniikka High Tech as well. I'm gonna be continuing on presenting this course live for you because I don't have too much skills to edit videos and stuff like that. So I'm right now sharing this video to my personal profile. So let's go. Today we're gonna be talking about the C operators. These operators are very important, my friends. I'm starting talking about these operators definition. In C, as in all the language we know, an operator, even in math, an operator is a symbol or to represent operations between variables, expressions, and values. When I'm talking about values, I'm talking about constants. Okay, all operators that we use in C, we can also use in C++, and most of these operators I'm going to present you today are also used or by all the C family, okay? C Sharp, language D, Java, Perl, PHP, and so on. But today, I'm gonna be starting about these operators, the arithmetic operators. These are the easiest one. The easiest one. We can sum, we can add numbers, subtract, multiply. The remainder of the integer division, this operator, this is called the remainder. This is very important. When we're dealing with integer numbers, mostly we're gonna be in need of the remainder of the integer division. For example, if you perform an integer division between 7 and 2, 7 divided by 2 as integer values, the result is 3, okay? Because when we dealing with integer numbers, we cannot have floating point values. So in this case, the remainder will be 1, okay? These are increment and decrement operators. These are quite important as well. Sometimes you have a variable and you want to increase by 1 or decrease by 1. But there are some differences. When you use these, the prefix increment, you first perform the increment and then you use the value. I'm going to show you in the practice session, okay, today. And this is the difference between these two is pretty much the same. Here we see in our screen the relational operators. Relational operators are used to perform a relation between two values of variables. When we're talking about these relational operators, the result is always Boolean. That means true or false. You can check whether two values A or B or X or Y are equals or different and so on, which is greater or less than the other. Also, we have these Boolean operators, which are the logical operators. 3. This is the not, this is and, logical and this is or. When you perform a not, if you have a true, if A is true and you have the negation of A will be false, and the opposite is true as well. With the and, whenever you have an and between two different values, this logical and, if one of the two numbers is false, is negative, then the result will be also negative. In order for this result to be positive, both must be positive. This is a little bit different, the OR, because when you performing the OR operation, it's only necessary for one A or B to be, or the whole expression to be positive. These are numeric operators. These are bitwise operators. Never mess up between these logical operators, although these are a little bit similar. For example, you have two ampersand here and two vertical bars here, but here you have a single vertical bar and a single ampersand. Okay, this is the difference. This is bitwise single operators. Okay, and this is the short. Not is the negation of some value. If you have a number, when you're talking about bitwise, you have to think on the number as binaries, okay? You think on all the bits of this number A, and each one will be apply the negation to each single bit, okay? And here you will be comparing each single bit from A to each single bit from B. If they are both positive, then the result will be positive for that comparison between those two. I'm going to show this in the practice, which is more understandable. The result will be a very different number in most occasions. This is the OR, this is the AND. Positive with positive must be positive for each bit. And here, if you have at least one positive bit, then the resultant B is also positive. This is the XOR. The XOR is a little bit different because this is AND OR, because it only needs for one bit, either the one on B or on A or on B to be to the whole expression, the comparison to be positive. But here on the XOR, the bits which are being compared must be different. When they are different, then the result is positive. Positive. When I'm talking about positive, a positive value is any number different to 0. 0 is the only number which is negative, which is false. Let me say false, because negative numbers and positive values are all true, positive, true. The only number which is false is 0. And these are two tricky operators. This is another bitwise operator to shift the bits to the left, and this operator is going to shift the bits to the right, the bits of a number. All these operators, you have to think about a number as binary and thinking about each single bit of the number. I'm going to show you. Don't worry. Here you have the assignment operators, too much. This is the assignment. You are assigning B to A, and these operators are a combination between the normal assignment operator, the direct assignment operator, and the others operator we saw before, the other operators we saw before. Here, for example, you have A plus equals B. That means A will be equal to the A itself plus B. This is the long form. This is a short form. Long form, short form, and so on. This is the operator precedence. The operator's precedence. Okay. The precedence. In order to control the precedence of your operators, you can use parentheses. Curved parentheses will allow you to have full control over your operations. Okay, so don't worry. If you in doubt which operator comes first, then use parentheses to have control on that. But if you don't use parentheses, the first operator with higher priority will be the postfix and postfix, increment, and decrement, and some others that I'm not going to show you today because are not too much used. Okay, so much used. These are the unary operators like prefix increment, prefix decrement, and for example, these are unary operators. This is to the negation of some number, okay? This is the negation, the logic negation. This is the bitwise negation. These operators unary are they have high priority, okay? Then you have the normal operators from math. These operators multiplication, division. This is the module which is the rest of the division, the integer division. These are the operators with between the algebraic or arithmetic operators. These are the one with more priority, like in the math. These are addition, subtraction comes after these, and then you have the shift to right and to the left. Then the relational operators in these order. These come first, and only the equals and different two will have priority. But after these operators, the bitwise operators, the normal bitwise operators, and XOR and OR will come after the ones on the top. Then, last but not least, you have logical operators, these, and then assignment operators. These are what I have to show you in theory, but let's go to the practice. Arithmetic operators, how that works. Arithmetic operator, I have some things here, some stuff. Let me delete this. I was already coding for my other channel, so don't worry. I'm gonna create a variable here, an integer called a. Let's say our a is 2 and our b is gonna be 7, for example. And then you perform an operation called sum. Let's say sum, int sum. You have a sum between a and b. A plus B. A plus B, the result, as you know, is going to be 5. All good? That's fine. Oh, I said 5. What's going on? Why I don't have 5? The result, this is a result. Let's call that sum, for example. I don't even know why I have here 2 instead of these. This should be 9, right? Let me try again. Okay, I have sum equals to 2. I have here a, which is 2, and I'm not thinking. I'm not thinking. I'm stupid, man. This is 2 because a is 2. I didn't want to print a. I want to print sum. Okay, the sum is 9. What about the subtraction? The subtraction is gonna be minus 5. You know that from the math, because this is a subtracted by b, not b subtracted by a, which is a positive 5. Okay, what if I put here a minus? This is a unary operator. The unary operator is only to negate this number, the negation. Okay, that's fine. What about the multiplication? B times a, that's 14, something like that. Okay, that's fine. Okay, let's go to the division. This is an integer division between 7 to 7 and 2. Okay, I have the division here. Sorry, let me call this result, not to change every time. Now this is the division. Let's call div. Okay, this is division. Why is that being red? Maybe that's some key, some used key. This is 3. Why 3? Some guys might be asking why 3 and not 3.5 or stuff like that. That's because all this operation is integer, and in the domain of integer values we don't have point values. Okay, but if you had something like float here, you would have something like that, something like this should be float. Okay, if you have a float, you have 3.0. Why not 3.5? Not 3.5 because both these two values are integers. At least one of them must be float. You can force them to be float. This is called I'm casting d to be a float. In this case, you have 3 points, and you can control these. You can put 3, for example. I have three floating points. Okay, 3. In this case, the division is not any longer integer but float, because the compiler is going to cast this by default. This is called an implicit cast, something like this float. The compiler is doing that internally because we have a float here. But if you didn't have a float here, then the compiler doesn't cast anything, and that treats as integers. Okay, let's go back to the integer values. As integers, we have these 3. Oh, I'm so sorry. I have to put here digit or an integer. And now we have 3, but we have a reminder. Let's see the reminder. Int the reminder. Reminder. We have the reminder. Let's call rem, something like this. And we have b divided by a, not this, but this, divided by a. This operator is the module operator, which means give me the rest of the integer division between b and a. Okay, the rest of the division, let's go, this is the rem, the remainder is 1. Which one? Because when we divided 7 by a, we had a result of 3, and 3 plus 3 is 6. What is the other one? The other one is the remainder, and is got using this operation. Okay, these are the arithmetic operation, and we also have some operator called this plus plus. Look, I have only one, because I have, why this is 1? On the next operation, let's see here. On the next operation, let's put here result 2 and some line break here. Okay, other line. On the next operation, check it out. The result 2 is true because here we performed the increment, but this is a postfix increment. What if the increment was prefix? If the increment were prefix, you'd have to 2, because first that's incremented and then the value is used. And here we're not incrementing anymore, we're using the 2. This is the difference with first increment, then use the value. Okay. Okay, these are arithmetic operations. Now let's talk about relational operators. The relational operators are stuff like these. Let's not use variables anymore. Let's put something like res right here. Relational. For example, if I say 1 is equal to 1, 1 is equal to 1. Let me put parentheses to have full control of my operation. 1 is equal to, is that true? The compiler is saying, yeah, that's true. 1 means true. What if I say 1 is different to 1? 1 is different to 1. That's not true. That's false. False is 0. Okay? False is 0. If I say 1 is greater than 1, that's false. But if I say 1 is greater or equal to 1, that's true. True is 1 and false is 0. But what about this? 1 is true and 0 is false. Yeah, that's fine. That's fine. This is fine. I wanted to show something else about logical operators. Okay, not only relational. These are relational. Let's use some logic. For example, 1 and 1. This is logic. Okay, 1 and 1. This is true and true. True and true is true. Always true. Okay. What if I say false and true? False and true is false, because the AND operator always gives false when you have at least one false. In order to have true, you have to have both values as true. But what is true? True is any number which is not 0. This is true. And this is also true. Any number which is not 0 is true. Okay? The only number which is false is the 0 itself. Okay? Now you have this other operator, which is the OR. I have a true here and I can have a true, that's true. If you have a false, this is false. The only false is 0, okay? True or false. True or false, you have true. In order to have false, you have to have two falses. With two false, you have false, okay? This is how the OR works. What about this operator, which is not? Okay, this is not. Not 0, not false. Not false means true. And not true means false, okay? That's how that works. Let's talk about bitwise operators right now. Logical bitwise, assignment operator before, and then bitwise operators, okay? Assignment operators, let's talk about it. I have a variable here, int a is equal to 1. That means this is an assignment operator. I'm saying 1 is assigned to a, or a is going to take this value. This is the assignment operator. But we have another way to assign. For example, you have a plus equals 2. That means this is exactly the same. A is equal to a plus 2. This is long form and this is short form. Okay, as a matter of fact, if you have here a, you'll have this 1 plus 2, okay, which is 3. Now let's talk a little bit about bitwise operators. Bitwise operators are stuff very used in strong scenario like cryptography and so on. Okay, embedded systems, yeah, you'll need to use this. I'm preparing a course of embedded systems. I'm going to have here a board, an electronic board for us to code using C. And when you have to program microcontrollers, microprocessors, embedded systems, hardware, or cryptography stuff like that, you'll need to know these operators. These are the AND. This is the AND, single ampersand. This is the OR. This is the XOR. This is the what else? This is the shift to the left, the arrow are pointing to the left, and then you have the shift to the right, the arrows are pointing to the right. Now let's use, we have to think on the numbers as bits. When you're using bitwise operators, this is why they are called bitwise operators. So let's talk about numbers in binaries, okay? If you have the number one, let's consider all the numbers are short. They have 8 bits. In this case, 1 is 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. And this is 1. This is the one in binary, okay? What about 2? 2 is something like this. 1, 2, 3, 4, 5, 6, 7, 8. And this is 1. This is 2, okay? What about 3? 3 is something like 1, 2, 3, 4, 5, 6, 7, 8. And this is 3. This is 3. 3 is 1. Is 1 plus 2. Okay, this is 3. And then you have something like 4, which is 1, 2, 3, 4, 5, 6, 7, 8. This is 4. Okay, I can explain better, but you can also check our lesson about the numeric values conversion, different numeric systems. You can check that there. Okay, we have 5. 5 is something like 1, 2, 3, 4, 5, 6, 7, 8. And then you have, this is called 1. This is called 2. This is 4. Okay, this is 4 plus 1, which is 5. Okay, and we have 6, which is something like 1, 2, 3, 4, 5, 6, 7, 8. And we have, this is 1. This is 2. This is 4. This is, sorry, 1, 2, double. This is double 2, which is 4. This is 8. Okay. But we don't need 8. We only need 4 plus 2. 4 plus 2, which is 6. Okay. And then last but not least, let's try with 7, which is 1, 2, 3, 4, 5, 6, 7, 8. We have 1. This is 1. This is 2. And this is 4. We have 7. Okay. In this case, if you have this short, this is 1. Okay. Normal 1. Let's put here. If you say something like negation of I, something like this, exclamation mark A. This is the negation of A. This is you negating A as Boolean. This is a logic operator. But this is not a logic operator. This is a bitwise operator. What that means? That means you have 1 and you're doing this like this. You're doing something like this. Now I'm negating each bit. This is no longer being 1, 0. Sorry, this is 1. Now this is 1. Now this is 1. Now this is 1. This is 1. This is 1. Whenever I find a 1, I put a 1. When I find a 0, I put a 1. If I find a 1, I put a 0. This is the negation of this number. Okay. This is different, man. This is different. You're seeing that -2. Why -2? What the fuck? I'm seeing -2. Why this is -2? Oh yeah, this is -2 because when you're dealing with integer values, this last bit represents the sign, the signal. If this is 1, that means a negative value. If this is 0, that means a positive value. The last number, the most significant bit, is used for the sign, for the signal. Okay. Most significant bit, this one for the signal, and this is the less significant bits, which has the value of just 1. Okay. So yeah, this is what it is. This is -2 because of this one. As you can see, if you put here something like let me put this in binary. Okay. I can say 0b, which means binary. I'm gonna put here 0, 1, 2, 3, 4, 5, 6, 7. In this case, I'm gonna have this is gonna be 1 as well. I don't want a 1 here. I don't want a 1 here. I want a 0 here. So I'm gonna put here a 1 and then 0 here. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay. In this case, we have a positive. What is going on? Am I wrong? 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is a negative value. Let me see this like this. Oh, this is positive. Am I wrong? Wait, let me check it out. I have this. This is the biggest. This number is something like 2. This is 2 pow. This is 2 pow. I can represent this. This 2 pow. 8. This is 2 power 8. Okay, because if you have 2 power 8 here in Google, 2 power 8. No, this is 2 power 7. That's 2 power 7. I'm sorry. This is 2 power 7. Okay, power 7. Don't worry about it. This number, something like this. Okay, because this is. I'm gonna show you better. I have a 0 here. You have a 1 here. This is 1. Okay, this is 1. Look, 1. Now take the 1. This is 2. Okay, this is 2. This is 2. Then this is 4. Okay, this is 4. And so on, and so on. Double This is 1, 2, 4, 8, 16, 32, 64. This is 64. Okay, 64. Oh, it's crashing. I don't like this because it's crashing. Let me copy the code so I can refresh this. It's crashing. That was crashing. I don't like when that crashes. Yeah, that was crashing, but we have our 64 right now. This is 64, and this is so 64, and then we have this 128 that we saw before. 128. Okay, 128. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay, 128. And what if we have some yeah, this is not giving me the negative value I want, but I know if I have 7 values like these, 1, 2, 3, 4, 5, 6, 7, 8, this is okay, this is the biggest value. Okay, I want a -1. How can I have a -1? Let me check it out. Not this. This is the biggest value, and this. What about the minus? I need the minus. No, I'm not getting the -1. Okay, don't worry, don't worry. I'm gonna go back. I'm gonna go back to our 1. Okay, this is the negation of 1. This is -2. I would like to know how this is going to -2, because -2 in this case is something like 0b. 0b. Let me see this. 1, 2, 3, 4, 5, 6, 7, 8. What about this? Not this, like this. Okay, this is bad, man. And this is 1. I have this. This is the biggest value, 2 and 50, 55. If I do this, I need to have zeros. I need to have zeros. Okay. Let me see this. Yeah, something is bad. I know what's going on. I know what's going on. This is because of this. This is because of this, man. I'm not using a short here. This should be short. Okay. This is something like let me see. Is this an H? Not an H. Short. Short. Short int we saw in last lesson. I don't remember. Short int in C. Short int in C. No, not C. This is short int printer format. This is the format. Okay. Format is something like, no, this is not this, not this, not this. No, not like this. I don't want this. I want C types. Let's see C types. I don't remember. I don't remember this. I was looking for short. This is HI. Okay, I was using H, but I was using H, but I forgot to continue. This is H. Okay. Yeah, like this. Now we have a negative value. This is a short, and now we can have something like this. Okay, now that's fine. Now that's fine. Now that's fine. Now that's fine. We have a short because before we have a D here, and the D is an integer, which means 32 bits. But we're working with only 8 bits. So in this case, we were wrong on using D here. Okay, that must be HIOHD. HIOHD, which means short integer. Okay. And now we can control our number, which is 1. If you have the negation of 1, you're gonna have something like this. This is what we want, like this. Yeah, like this, like this. Okay, -2. This is something like this. Wait, that's not good. I don't like this. If I have this 1, 2, 3, 4, 5, 6, 7, 8, and we have this, what's wrong? 0b, 0b. Then you have negative. Now you have positive, and this you have negative. Okay. This is the negation. That's not fine to me, because I want to the negation of each bit. If I have something like zeros, let me say 0, only 0, then we have this -1. Okay, that's fine. That's fine, because -1 in binary is something like -1 is something like this. -1 is 0b, 1, 2, 3, 4, 5, 6, 7, 8. This should be -1. But I don't know why this is not working as short. This must be short. As short. That should be -1. No, that's not fine. I don't know why. I don't know why I'm not able to work with short like this. That's bad. Because if I had an int here and I have stuff like 1, 2, 3, 4, 5, 6, 7, 8 is 8, and then I have another 8, another 8, another 8, 32 8s, 0b, 0b, and then you do this, you have zeros, and now we must have what we want. This is -1. That's right. That's what I wanted with short, because when you have stuff like this, stuff like, no, not like this, let me call this int b. You have stuff like 0b, and then you have 1, 2, 3, 4, 5, 6, 7, 8. This is 8, 16, and then you have more 8, 24, something like that, and then you have 32. This is all positive. The b is all positive. If you do this, b will be all negative, which is 0. That becomes 0. Okay, and that the negation of a becomes -1. -1, because when you have all the bits filled, then you have a -1 because of this. When you can see, like, b is a -1. Okay, but this is not negative, because this is the negative. This is the signal negative. Now you have a positive value. Why is that positive? Why is that negative? That's not good. Wait, this is negative. Sorry, this is negative, and this should be positive. Yeah, today I'm getting, this is freaking me out. Wait, what about this? 0 negative values. Wait, like this. This, no, that's not good. This is bad. Wait, b. What am I printing? B. Oh yeah, this is short. No, it's short, man. Like this. Okay, I'm sorry. That was short. Okay, that's fine now. Oh yeah, oh yeah, oh yeah. No, that's okay. That's fine. One more. I know why I was having that problem. Now I can show you what's the problem. This is quite important, because when you have this kind of overflows, when you have this kind of issues, that means we making things wrong. Okay, I was making things wrong, because short is not 8 bits. Short is 16 bits. This is 16. This is 16 and not 8. And this is 8. Sha is 8. Okay, now it's gonna work. This is 8. Let's go. This is 8. Okay, this is 8 bits, like this. 1, 2, 3, 4, 5, 6, 7, 8. This is 0b. In binary, this is -1. Now this is -1. Okay, this is -1, and but I'm wrong because I have to put here short integer. That's fine now. Okay, this is -1, and this is the positive value because this is the signal which was negative. Now you have the number. That's fine now because now we have this. We have 2 power 7, which is this number. This number. Okay, 2 power 7. I showed you 2 power 7 here is like this. Okay, yeah, -1, -1. But now you have this is the negative, and now let's do the opposite. The opposite would be something like if I have 0b, and then I have 1, 2, 3, 4, 5, 6. I have 6, 7, 8, and then I do this. This is -1 because all the bits are gonna be 1. And now if I have a 1 here, it's gonna become 0. Now we have -2 because this is another bit. This is something like this. This is -2. This. When I the negation of this is this. Okay. Now we can perform good operations like we can put here something like 0b, and we have 1, 2, no, not I want 1, not 1. I want a 0 here, a 1 here, and then 1, 2, 3, 4, 5, 6, 7. And then if you do the negation of this, then you have this. Then you have 0. This is going to become a 0, and the others are going to become a 1. Okay, and then you have this, which is equals to this. Okay, and that's fine now. That's fine now because this is good. This is how the negation works. If you have something like, let's call this one. This is, yeah, that might be 1. Let's put 1 for everything like this. Then you have ones, and then at the end, 0b, sorry, 0b. At the end, you can put here something. No, let's start like this. This is minus this. Okay. Then we can work with our 1. With 1, we have this. Okay, -2. -2 because 1 is something. -2 is something like 1 is something like 0. 1, 2, 3, 4, 5, 6, 7, and then 1. This is 1. This is 1, and the negation of 1 is something like 1, 2, 3, 4, 5. Am I right? No, sorry. 1, 2, 3, 4, 5, 6, 7, 0. Okay, like this. A is 1. A is 1. This is 1. The negation of A is -2. What is -2? Is -2 this? Let me put it here. Am I wrong? 0b? 0b. Yeah, this is -2. Okay, this is -2. But if you have, yeah, the negative values are a little bit tricky because this is why I don't want to work with negatives. I don't want a negative values anymore. I want values like positive values like this. I have 1 here, 0b, 1. This is negative. 1, 2, 3, 4, 5, 6, 7. And then let's start from this. I can have this. This is something like minus this, and the negation of this is something like positive. This is going to be positive because all these are going to be 1, and this is going to be transformed into 0, which is positive. Okay, and what about something like I would like to work with smaller values, okay? For example, if I have something like 1 here, this is 6, and with another one here. I don't like these examples. I don't like these examples. I would like to, this is 1, and this is something like this. 1. What about 2? If I have 2, I'll have something like minus. Oh yeah, I have a good example. A good example maybe something like this, -1. Okay, -1, all 0, because -1 is everything. -2. Let's start with -2. -2. I didn't want to work with negatives like this, because -1 is something like 1, 2, 3, 4, 5, 6, 7, 8. 8. This is -1. Okay, this is -1, and -1 is this. And when you do this, the negation of this, you're gonna have zeros, all zeros. Okay, but if you had something like -2, you're gonna have a 1, because -2 is something like this. This is -2. Okay, -2. And then if you have -3, -3 is something like this. This is -3. Okay, this is -3. And when you do the negation of this, you're gonna have all zeros here, and these bits represent the 2, as you can see here. As you can see, no, this is bad. 2 is only 1. This one, this is 2. Yeah, so if you want to work with this, you know this is a little bit tricky, but I can show you some operations about this and this. When you have, for example, a 1 here, and you want to use an AND, for example, you have 1 and 1, stuff like this. 1 and 1 means this and this. This is gonna be 1. But the good example I like to present to the people is something like 5 and 7, not 7, 6, 5 and 6. This is 6. Okay, this is 6. I can show you. This is 6, and this is 5. I'd like for you to study and leave in the comments some more stuff about the negation, the negation, which is a little bit tricky because of the negative values. Okay, but now this is easy. This talking about, this is the 6, and this is 5. Okay, 6 and 5, as you can see, and 0 is always 0. 0, 1 and 1 is 1. So you have 1 here, 0, 0. That means the result has only one number here, 1, 1, 1, 1, a single 1. This is the one which represents the 1. This represents 2, and this represents 4. So the result of this is 4. Okay. Oh, I'm sorry, because of this, result of this is going to be 4. Okay, 4. But if you have something like OR, bitwise OR, you have this is 1, this is 1, and this is 1, because OR admits at least if there is at least 1 OR considers the operation as 1. This is why you're going to have 3 1s, and 3 1s means 7. So you have 7 here in the result. Okay, what about XOR? XOR is a little bit different. XOR doesn't like same values. For example, 0 and 0 false, because they are same. 0 false, 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 false. 1 and 1 false, because they are the same. 1 and 0 true, because they are different. We are different. In this case, we're gonna have 2 1s here at the end. 1 and 1. So the result of this is gonna be 3 because 3 is this one. When you have 1 and 1, this is 3. So you have to study a little bit more about these operators. Then we have these operators, like I have a 1 and I need to shift some bits, 2 bits to the left. 1, if you shift the bits to the left, then this one is gonna be in this position, 1, 2, 2 positions, okay? And if you have a bit here, this is the 4, okay? Not any longer 1, okay? For example, if you're shifting the number 3 by 1 to the left, then these 2 bits are going to move to the left 1 position. So in this case, you're gonna have a number like 1 here and 1 here, which is something like 4, 5, okay? No, this is 6. I was wrong. I'm shifting one number. Let me put here this. I have this, and then I'm shifting this. This is gonna move from this position to this position, and this is gonna move from this position to this position, and this is 4 plus 2, which is 6. Okay. Oh, I'm sorry, because of this. This is 6. This is how the shift works. If you do in the opposite direction, you have this is a 3. You're moving to the right, then you lose the last one and you keep a single one, then you have a 1. Okay. But if you do this on the number, for example, this number 6, or number 6, to the one position to the right, this is going to be here and the other is going to be here, so you have the number 3. Okay, the number 3. But if you go two positions, then this is going to go one position to the right, another position, you lose it, and then the other is going to be at the first position, so you have 1. Okay. When you performing shift to the right, you're decreasing the value. Shift to the left, you're increasing. Okay. Thank you very much for watching. I'm so sorry for these bitwise operators. They are a little bit tricky, but you can practice a little bit more. Leave something in the comments, and I'll see you next lesson. We're gonna be talking about um, the ways to create algorithms: sequentiation, condition, and repetition. On the first lesson, I'm going to teach you how to think as a good programmer, how to idealize your algorithms. Okay, thank you very much. Subscribe my channel on YouTube. Put a like on Instagram and Facebook, also on Twitter. Tekniikka High Tech. Thank you very much. See you next time. Next week we will be together. Leave comments. I will answer you